Good day, my name is Brandon Shepard. I'm here to speak to you today on digital beamforming. Digital beamforming is a variation of beamforming in itself. Beamforming, a quick history of, is a signal processing technique that is used primarily to remove desired data or signal from undesired noise. Conversely, it is also used to remove what is undesired away from a desired signal or desired data. Beamforming requires the application of either an antenna array or a sensor array. As depicted over here in figure 1, we have an antenna array that is used for the transmit purposes. The transmitted signal along this blue line right here, which is marked theta, originates from a single point of this transmitter, which is then broken up into 8 individual antennas within the array. Now this array of the 8 antennas, with each antenna angle of modulation is done in a manner in which the angles of transmission can overlap one another, as I'll show here with this purple line. However, in the overlapping, they do not impede one another. That also allows them to transmit along whatever desired line it is, in this instance, again, as the blue line theta, which gives this entire array the ability to not only have a higher signal capacity, but also a longer line of transmission, given that they are all coming from a single source. Now, what it also does is it allows this signal to be transmitted in its purest form and mitigates undesired noise from being able to enter in, because all of the angles of modulations are matching one another, and that way undesired signals cannot access this of which is desired. So the application for beamforming has a very, very broad range, a broad scope. It can be used in not only radio, but also sound waves. It has applications in aircraft radar, ground radar, Doppler radar for that matter, but also in sonar. But given that we are specifically speaking about digital beamforming today, we're not going to be hitting on any of those topics with any specificity. So we will now get into what is digital beamforming. Digital beamforming began, or was first proposed in 1980, but there were great limitations in the application, the scope, and the research of digital beamforming. The reason for these great limitations was due to the physical limitations of the analog to digital converters, also known as ADCs, going forward. Now we see here in figure 2, this is standard beamforming. This is not digitized, so this will be analog beamforming right here. And what we see is on the receive mode, okay, is coming in 3 different signals into what is 3 different antennas. 3 different waveforms entering in, seen as X1, X2, as X3. They hit this block here, which they are all summed together, and then formed into one central beam, denoted as Y. It is a very good source, or excuse me, it's a very good application for removing what is undesired, in that when these are summed together into a single form of Y, that allows anything that is undesired to be easily removed, not only removed but also identified. Back to digital beamforming, we see the difference in that in talking about the application of the analog to digital converter here. We see in figure 3. After receiving or coming from the antenna, that is where the signal itself, the analog signal, is then converted into into a digital signal. The ADC back in the 1980s and prior to that was greatly limited in its capacity. Therefore, it had to be very big, very large, almost on the industrious scale. That was not a limitation for ground application, as payload and volumetric size is not a criteria that necessarily has to be met. However, in spaceborne and aerial application, it is of great concern for payload not only to meet the constraints of size, but also weight. as you can see here in figure 3, this is greatly cleaned up. When we go all the way from what was figure 1 all the way down to figure 3, we can see that merely just in two antennas, bringing in an analog source that is now digitized through the ADC. Because we are digitizing these, a fast Fourier transform, FFT, has to be applied to the digitized signal. The digitized signal is then able to be selected from, and here we see these two blocks labeled as beam select. The purpose, again, of the beamforming is to mitigate undesired noise and to remove that from what is desired. The purpose, more specifically, of digitized beamforming is to bring that great scale that is required for the beamforming operation into a much smaller application and physical parameters. Digital beamforming has several characteristics that are much desired, much sought after. Again, it's mostly in that of the size and payload applications, therefore can be spaceborne. But also in not allowing these undesired signals to come in from the side, as depicted in figure 1, it does not degrade the signal to noise ratio, which is also known as SNR. So in conclusion, the digital beamforming has many characteristics that are much sought after, especially that for airborne and aerial application. It is much smaller in payload and much smaller in size and weight than that is of its analog digital beamforming, its analog beamforming background. That is all I have. Thank you so much for your time, for your attentiveness, and have a good day.